Okay, well, I will go ahead and get started. So I would start a little bit with who Paul Gerber is, a little bit of some of his products, how I met him, some scenes from his workshop in general, and then the 3 days of the workshop. I will first start with Paul Gerber is. Okay, so this is a book by Elizabeth Dorr. She's a journalist that you see out there quite a bit, and she wrote a book, 12 Faces of Time, and this was the first book that I had gotten with Paul. So in the book here, you see this is a type of little minivan that Paul Gerber is a big fan of. And then he's a member of the Academy of Independent Horologists, which is AHCI, a French acronym. And so there's, some pictures of some of the products that he's done. When you're inducted into the AHCI, you have to do some sort of little presentation project. And one of the project that Paul Gerber did was this little striking wooden works clock, because he decided he didn't have enough time to put together something out of metal. He did it out of wood, and it's actually in the Guinness World Books as the smallest striking clock out there. And typical of a lot of these small clocks, the pendulum actually hangs off the front. So that's what that wire is on the front. Paul also has designed a chronometer escapement that uses uh, 3 pallet jewels and a dual stacked escape wheel design. And he uses that in this Model 33 caliber. He does some other things. He's known for this particular watch, which I'll cover more in detail later, which is they call it the Muller or the Piguet Muller Gerber ultra complication. And it started off as an antique Piguet women's Grand Saunier repeating pendant watch, and Frank Muller converted into a wristwatch back in, I think, the early 80s or mid 80s or 90s. I have a book on it. I can't find it. He also collaborates on other things. This watch here is the MIH watch created by Ludwig Oechlin, who was the designer for the restart of Ulysses and Arden to raise money for the International Museum of Horology in Chafonds. Paul also does a tourbillon clock, 8-day clock, and then he also collaborated with Ludwig Oechlin and his son on this watch down here that I forget what they call it. So this is one of his 8-day pendulate clocks that was delivered to a collector here in Boulder, who actually was also a member of the Boulder Horological Society. And Paul Gerber has a dealer here. His name is Hurdle's jeweler. Keith Hurdle is the owner. He's the, I think, second generation owner of the jewelry store, and he's Paul Gerber distributor. Here's just pictures of the clock. So this is all handmade by Paul in his workshop, other than the stone case, which comes from somebody else. And I believe, I don't know if the hands and the numbers are fabricated in-house or if he sources those from somewhere else. But it's a very attractive clock. There's Keith Hurdle, and this jewelry store is on the Pearl Street Mall at the corner of 14th and Pearl Street. And that's the backside of it. More close-ups of it, and this will show the tourbillon working. I don't know how many of these he makes, but there are not a whole lot of them. So I met Paul Gerber in Baselworld in 2013, and we went there because Baselworld had been delayed. Normally Baselworld is in March, sometime about middle of March, which is not a particularly great time for Swiss weather. But they had pushed it back to the end of April and early May because they had just we're finishing up a major construction renovation of the exhibit hall. So it kind of coincided with the start of the spring river cruise business. And so we went to, my wife and I went to Basel World first, and then we went to Amsterdam after that. And then we did a Rhine River cruise that brought us back to Basel. And from there we went to Zurich and then back home. But while at Basel, this is the new structure that they built. Actually crosses over a road, spans both sides of a thoroughfare with train traffic and everything else. It's quite an interesting building. And inside, it's you got all the big brands. But they've got a booth that is the AHCI booth, and so the members can buy exhibit space there, and it's a lot less than trying to buy a full-size booth in one of the other halls of Basel World. So this is a Paul Gerber display, and I didn't know him. I just knew what he looked like, and I had an MIH watch that I had bought in 2010 on this trip, and I had bought one other small, one of his early watches off Time Zone's sales corner, and so I saw Paul Gerber there, and I introduced myself to him, and he doesn't speak a whole lot of English, but I, told him that I was a fan of his watches, and told him I was from Colorado and Boulder. And when he heard that, he got really excited and said, wait, and gets out his cell phone and, calls somebody. And turns out that Paul Gerber's representative for the United States, importer, lives here in Boulder County. His name is Michael Schmutz. And Michael used to be the importer for Minerva watches. And Paul Gerber had looked at the Minerva caliber 48 as the base movement for his flyback watch design. And so Michael had made a connection with Paul Gerber at that point. And then Michael got laid off when Minerva was sold to an Italian investment firm. So Paul Gerber picked up Michael as his rep for the importer for the United States. Michael had gotten Minerva into Keith Hurdle's shop. So when Minerva went away, and Michael picked up Paul Gerber, then that's how Keith Hurdle got Paul Gerber franchise, so to speak. So this is the neighborhood, the end of the road where Paul Gerber lives. It's right on the outskirts of Zurich. It's at the base of Little Zurich Mountain, an open space, and this is his house. It originally belonged to his wife's parents, and they've taken it over and renovated it, and he has his watch workshop in the basement of it. And when I met him at Basel World, when we were back in Zurich, he contacted me and said if I wanted to come over, I could visit his shop. And so I did that. And he's a pretty modest, simple guy. And rather than using fancy electronic PowerPoints, he's got all his promotional material that he pitches to collectors and people on these foam boards on chains that move on sliders, so he can slide them out. Here he's showing some of the things that he's collaborated on: Fabergé automatons and other one-off products. He's done design work and actual fabrication for. So you can see some of these various things: some miniature moon phase clock movement. Here he's showing some of his work that he's done. This is the Frank Muller Gerber collaboration, tourbillons. Fortis did the first chronograph-based alarm watch, automatic alarm watch out there, and it turns out that Paul Gerber designed the alarm complication for them. So that's in his repertoire. These retro twin watches, they've sold quite a few of here in Colorado, and they basically are called retro twins because you have this retrograde kind of flyback seconds display down here that he's got a patent on. And then it's got two twin winding rotors that is his proprietary design. And again, these watches, he does the dial in-house. I believe he does the numerals in-house are applied. The case is done by a case fabricator, and the base movement is a standard at a thin movement that he adds the auto wind system to. Here he's talking about his pendulette clock. He calls this the caliber 33. So it's got this chronometer escapement that he designed, and it also has a three-dimensional moon phase. So it's got a little ball that's half blue, half gold. And in some of the cases, they're like a pave set with diamonds, depending on things. And this is collaborative work that he's done for other people. This is not a clock that he sells directly, but it goes into somebody else's product, I believe, Fabergé. And this is his certificate for completing the world's most complicated wristwatch. And this is an interesting watch, and I'll show you pictures of it later because it started off not having a tourbillon, and Frank Muller had this platinum case made for it, and the dial and a perpetual calendar module created for it. But otherwise, it was the same base movement. And then the owner of the watch decided he wanted it to be added to, and he wanted a tourbillon added to it. So he asked Paul, well, he contacted a lot of people, and finally it was Paul Gerber that said, sure, I'll do that, even though Paul had never made a tourbillon before in his life. So it became the start of a long and interesting process. And Paul has spent 25 years working on this watch. You know, obviously not full time, but it's been an ongoing project, and he's sort of been on retainers. This is the MIH watch, and so this is what they call an annual calendar. So it has the day of the week, the month, and the date, and it's based on a 7751 movement, but you don't have any of the subsidiary dials on the front because there's no room to bring the shafts through with all these date discs in there. But it's a nice watch, interesting design. And this is he's showing, this is what he calls his caliber 41. So this is a triple rotor design. He's gone to triple rotors now, larger design movements and cases. And this watch is his own movement design, and he builds it completely in-house. So this is an in-house built movement. And then he's showing this model 42. The model 42 is based on a 2824 ETA movement, but he puts a proprietary triple rotor movement on it. And he also has put a much larger diameter date disc on it. So rather than doing these large dates like you'll see where they've got two little discs with large printed date numbers on them, Paul has just done a much bigger diameter disc, which you can put bigger numbers on, and this sits on the outside of really the movement. So this dial has no dial feet on it. It's actually attached to the case, or is kept in place by the case, I should say. And here he's showing off a little clock. I guess that's the movement that he was showing before, where it had the moon phase on it. So that's a brass design. So this is a little thing that he has hanging in his workshop. Just kind of cute. And some other little miniature watch. So here's a movement for his pendulette that's not tourbillon clock that's not finished. And if you want to diagnose the escapement on a tourbillon clock, it's hard to do if the tourbillon cage is moving. So you build these little test jigs where you can get the escapement all set up without the tourbillon moving, and then you assemble it. And here he's showing part of the tourbillon cage unfinished. So these are as they come off his CNC machining system. More things, tooling for polishing pieces, little clocks that he's built. Here's a Fabergé egg prototype thing that he had in there, pieces for the MIH watch, and showing some steel parts that are machined, come off a steel plate. This is his caliber 42. this button on the side here, you can switch the second hand from a smooth running sweep to a jump second sweep. And that button toggles between it. They're showing the triple winding rotor on the back. These are raw parts that need to be finished. There it's obviously not finished. This is part of his winding rotor assembly. So that's a gold weight. So this is the 42, calls it Synchron. This is one of his characteristic designs, is green with these numerals. And then he also offers it in a pilot version with more traditional hands and traditional pilot style dial. MIH movements waiting to go out the door. And this is the school watch. This is the first one that he did. His wife was his very first guinea pig on this watch class project. So this was his first attempt at doing it. This is a commemorative watch that he did for the Swiss rail system. And this actually is showing, for the Zurich rail system, this is kind of showing the map of the Zurich rail lines. This is some of the tools in his machine shop. This is a small jig boring device, which is basically a very accurate device for that you can read out dimensions on or precisely place holes. And he used this machine quite a bit on that ultra complication, because he had to measure the project started pre-CAD systems. So he had to measure everything by hand and create the parts by hand using machinery like this. This is, another view of his workshop. More workshop views, a lathe. You can see this is a dividing plate on the back for gear cutting if you're going to manually cut gears. This is Paul's workbench, so it's not as bad as mine, but it's still a bit of a mess. Yeah, this is one of his projects. He likes to take cheap alarm clocks and turn them into tourbillon escapements. So this is some, cheap equivalent of Swiss equivalent of a Westclock's Big Ben that he's converted to a tourbillon cleaning machine. But this little thing over here is a screwdriver sharpener, which is kind of a cool design. This is a small CNC machine that he uses for doing all of his modern computerized fabrication on. These are kind of standardized brass blanks that you see in the Swiss watch industry that have had things cut out of them already by the machine. So those will go back and be recycled. And that's a drain on the floor of his workshop. That was kind of fun. This was his first CNC machine that he had made. So it, was actually a hand-built machine sitting on a Schaublen 102 style lathe bed with an early CNC stepper controller. The spindle on it is an air bearing spindle that runs at about 45,000 RPM. He still uses this for doing his dial work. So all of his dials, they look like they're hand cut on a Rose engine or a straight line machine, but they're actually cut using this particular machine. And he's into these little model airplanes that you string attached things that you used to fly as a kid, standing in the middle and getting dizzy. So that's one of his hobbies. And then more of these little European minivan kinds of cars that he collects. This is a book he had. It's The Watchmaker Under the Workbench, the classic story of all of us want to be watchmakers, where you're looking for that lost part on the floor. So that ends that presentation. Hopefully I didn't bore you too madly with that.
How many people work at his shop?
When I was first there in 2013, he had two young German watchmakers working for him, and now he's in retirement, and so he's working alone. Other than he has one worker that comes in on and helps out when he does these watch workshops, or if he's got something that he needs assistance on. He's still building watches. He's doing them in lots of about 10, and I don't know what his production rate is per year, but it's not real big. So anyway, this is the start of the watch workshop, day one. And I forgot to mention that when I was talking to him at Basel World, he pulled out a portfolio and he showed me some pictures of what was to be this binder workbook that accompanied the watch workshop. And he said, I'm wanting to do this workshop and I am, is this something that you would be interested in? And I was going, oh, yeah, I definitely want to do this. Me thinking that he'd be doing it somewhere in the US for, maybe a bigger group of people, like 10 or 12 or 20 or something like that. So I get a call from Michael several months later saying, okay, Paul's wanting to do his watch workshop. He'll be in Zurich, 4 people, and he wants to do it on this date. Are you interested? And it's like, damn, I was just in Switzerland, less than 4 months ago or 6 months ago, and I'm not sure I'm, wanting to go back on my own and all this sort of stuff. But I thought, well, I'm probably not going to get another chance to do this. So I said, yeah, I'll do it. And at that time, it was like $5,000. And I don't know what it is now. So I met Michael there in Zurich, and I arrived a couple of days in advance to the workshop, and we toured around a little bit, visited a cousin in Basel and toured the city. And we did some touring around Zurich and the area on our own. And then the workshop started. So there's 4 of us in this workshop, and it was a conductor off the Bernese train system, which is the system that has the Glacier Express and goes from Italy over to through the Alps and such. Extremely scenic. So we had Hans Peter, Steve, a gentleman from Hong Kong whose family is importer for Paul Gerber there in the Orient, and Paul, who is a jeweler that collaborates with Paul Gerber on various jewelry kinds of things, mostly for Middle Eastern clients. It's kind of an interesting world. So he has this book and he's showing us, what this watch is going to start off with and what we're going to end up with. So these are plates coming off his CNC machines and other parts, and then we finish them and it looks like this when we're done. And there are some pictures of it, and this was, I don't know whose watch it was, but this was, what it's going to look like. And at this time it had a black factory produced dial and hands from someplace else. And then this is what he does now. He does metal dials that you can choose different patterns on and choose different hands as part of your workshop experience. This is his own watch. So he starts off with a little bit of watch theory. He's showing us movements, some large ones, so you get an idea of it. This is Hans Peter. This is what he would rather be doing. So, he's passing around various types of movements. And then he's showing us the movement that we're going to be working on. This is a Unitas ETA 64 and 98 movement. It's a modern pocket watch movement, but it's used as a base caliber in just a large plethora of independent watchmakers' watches. And Panerai uses this movement as well in some of their watches, although they use the 97, which has the small seconds actually at the 9 o'clock position. So he's using a microscope, video microscope, projecting it on the screen, and he's going through showing us how we're going to take this movement apart. So he kind of goes through the disassembly process. And then these are all our kits. So we've each got a little plastic parts box with our name on it, with a case and parts that he's fabricated for us, and some brass tooling pieces that are used to hold the pieces that we're going to work on. So now we're going to get started in the workshop, and there's 4 of us, so we all can't do everything on the same machines at once. It's not all that efficient. So we try and split us up into doing different things simultaneously, but you're kind of showing it, he's trying to show us this is what we're going to be doing now. You do this and you can go off, do this on your workbench. And these are the 2 German watchmakers that were helping us. I think the tall guy's name was Martin and dark-haired guy was Lucas. First thing we have to do is take our existing ETA movements and actually time them to make sure that they're working properly, and we want to get them to work as well as they did when we're finished as when we started. So we put our movements on this tester and it automatically moves this holder in 6 different positions. This is what you end up with. So you've got this little paper printout of the performance of your watch movement. So here this is Steve, the gentleman from Hong Kong. Here, Lucas is preparing some polishing plates. These are tin plates that Paul actually made. So it's a brass tube that he's machined down, and he's bought pure tin from a foundry, and he's melted it and poured them into these brass cylinders and then machined them on a larger lathe in his garage to create a flat polishing surface. And then they use different levels of diamond powders on them, lubricated with a little bit of D5 watchmaking oil to polish your steelwork. They're showing the plates are covered with saran wrap. And these are metal holders for holding screws and such. And I'll show you more of those close up. This is my workbench area. And about every 2 hours, we'd break in either, for mid-morning, mid-afternoon break or go to lunch. And Paul would say, okay, everybody come around and I want to show you something. And so here he's showing kind of the principles of how shock absorption works on the balance shaft as part of it. And then our first machining thing that we're going to do, he has us doing a variety of things, machining, flat polishing, doing anglage, chamfering, plating, all these different things he wants to introduce us to. First one is we got to make the locating pins for our plates. So he has this drawing that's, of course, CAD generated, and he's telling us what we're going to have to do. And here Michael is translating a little bit, but he's got a Schablin lathe set up, and the cross light is set up and calibrated to our machining and needs. And so we basically have to create these little teeny pins. And so we start off with brass stock and machine it down to the correct size. We have to check the dimensions of it, and then we actually have to cut them off with a handsaw. Now he's showing us how to clamp our movements plates into a little machinist vise, and we are going to start polishing the edges using a file. So he's going through the process and showing how we're going to finish the edges. We also have to heat harden some steel winding ratchet parts. So he's demonstrating to Paul how we're going to do that, as some of us are doing our machining operations. Basically, here you'll see more pictures of it, but he's taken the unhardened steel parts that came off his CNC machine, wrapped it in iron wire, you heat it a little bit, dip it in borax, and then you heat it a bunch more, burn the borax off, and then you dunk it in water and you dissolve the remaining borax and harden the steel. Here's the movement plate at my workbench showing the edges that I've been working on, trying to smooth out the machining marks. Here's the steel part wound up in the steel wire for hardening. He's just saying this is how you do it. And here he's heated it and dipping it in the powdered borax, and then burning the borax off, which is a flux, keeps the metal from oxidizing. And you get it hot enough to where you change the arrangement of the carbon atoms in the metal matrix, and that leads to the hardening process. And then when you're done, it looks like that. So that concluded day one for me.
Tim, it seems like there's so many steps along the way where you could just be off a little bit.
Yeah, there are, and he does, help you along the way if you have problems, and the 2 other watchmakers would also help. In today's scenario, according to Michael, and Michael isn't really too connected with the watch workshop program, because he does about 3 a year for 3 people now, and I think He does it either over 3 or 4 days, with 1 day in between where the students are not in the classroom and or the workshop, and Paul is instead working on all of their problems, trying to get things dealt with so that the class will stay on track. So here he's showing us what we're going to do with the screws, and we're going to be bluing the screws, but first we have to polish them. So what he does is there's a brass plate that we put all of our screws into, 2 brass plates, and once the screws are in there, we then sand them on. This is sandpaper glued to a piece of glass. Basically just shows, you're doing a circular motion. And this is doing 2 things. It's taking the machining marks off the screws, and it also is removing the plating on the surface of the screws, because the screws are all nickel plated and they will not blue if you don't remove that. And then after we've gone through several grades of sandpaper, we then go through the polishing on the tin laps with the diamond compound, and then you try and get a mirror finish onto the screws. So these are the screw holders that we have as part of our kits. And so these are the screws that hold the bridges, and they go onto the plates. And you can see that there's sort of some, roughness to them. This is a chaton that holds the escape wheel jewel, and so we also put a circular graining finish on that using this little holder that he's created. So we've screwed that on and spin it in the lathe, holding some sandpaper in it, and you see a little bit of sandpaper residue in the center there, which I never got completely out when I set the jewel in there, and that prevented me from getting that part assembled properly until Paul um, figured that one out. These take a couple other screws, are winding screws, and 2 other, those would be the screws that hold on the pallet bridge. And this is a plate where these are sunk at different levels so that everything is at about the same height. So here we're ready to polish. And this is a beveling. This is basically polished carbide, and a teeny little ball that is holding a tool that's holding the escape wheel chaton. And there I'm going to be polishing the edges using that. And then you also countersink the hole using this steel cutting tool. So it puts that bevel on there. And then I've sort of done this with that burnishing tool, that carbide burnishing tool. And here I am doing the polishing. So here, these have been sanded and these haven't been. So you can see the machining marks on the bigger screws versus the screws that got sand marks on them. And then they're both sanded. And now I believe those are polished. Here's a polishing lap. And then it's time for our morning break. And so Paul wants to show us a rounding up tool. So he sets this thing up, and these are used for cutting gear teeth or shaping gear teeth. And you can also use them to reduce the diameter of gears. So if you've got a gear that will work for you, but it's a little too big, you've taken it off some other parts movement, you can stick it on a tool like this and cut the teeth down. So he's demonstrating that, and he's showing the cutters how they are, how some of these they're specified in the catalog. I've never seen stuff like this. I've got cutting discs like this and rounding up tools, but you never know what they mean. Now the screws are polished, the screw heads are polished, but we want to bevel the slots. So we're using another little hardened steel pointer, and we basically run that back and forth across the slots of the screws, and that rounds off or puts a bright bevel on it. Again, with all this beveling, Paul is saying, you want this to be at about a 60-degree slope because that reflects the light better. If you do it at a 45, it just reflects the light back inside the watch and it doesn't appear as a bright edge. Now we're going to blue them. So we hook them onto these pieces of brass wire, and he takes us to this propane camp stove with a stainless steel coffee mug on it with some hard white compound in it. And it turns out it's gun bluing salt. So it's, I think, sodium chlorate or something. Rex Pogenpaul knows this because he's gone through gunsmithing courses, but you basically heat this up to about 400 degrees, and that white solid liquefies, and then you put the items you want blued in there, and then you watch them, till they start to turn blue. And when you get them to the level of blue you want, you pull them out, dunk them in water, and lo and behold, you got blued screws. So you notice that the slots are white and the edges are white because they're still nickel plated and they're not going to change color. They're not going to oxidize. But the blue is actually an oxide coating, heat induced on the surface of the steel. So here we are. There's my main bridge, and these are the original bridges of the Unitas movement. And we actually have to transfer the jewels out of there and set them into our bridge. So, and these are the other parts of the watch. So now I've got this, I've flat sanded this on those same sanding plates that we did the screws on, trying to get the machining marks off the surface. And then we're using a file to chamfer the edges. And again, we're trying to get that 60-degree angle on there. And now we're got to do a little bit of threading. The chaton for the escape wheel and the nameplate are held on with screws, and those have to be threaded. So we use a staking tool that's got a little miniature tap clamped into it, and so we actually thread the holes. This little slot is where the nameplate goes. These are the brass pins that we had to machine to locate the balance cock and the main plate into the movement. And these are the steel winding click and the click spring that we have to harden and polish. So this is a little nameplate that I have, and this is the escape wheel chaton that's finished. So here I'm beveling the screw edges, and the jewel holes also get beveled the same way. And so here I've got one jewel already set, the center wheel jewel. We use this little jeweling tool, and you first have to measure the height of the jewel in the existing original plate and write that down, because you're going to set that in our plates that we're working on, at about the same level. So here, Steve is going through the process. So here's another jewel pushed out, and we chamfer or bevel both sides of the plate. So here I'm pushing the jewel in, and that's the end of day 2. And then we get to day 3. So here we're continuing to go through the, trying to get the jewels set in these plates. And again, there's a little micrometer readout on this jewel setting tool. So, that's what you use to read off the depth that you're going in. And Paul checking the work on some of our stuff here. Looks like he's doing some jewel adjusting. Now he's showing us some additional polishing, or this is a polishing triangle, and he's showing how you would do one single part on sandpaper. But for us, there's 4 of us, so he had built these plates that you could put 3 pieces on, because I think his intent was to do 3 people size classes. And so Steve and I got the job of doing this, polishing the steel parts for everybody else. So we glue them onto these brass plates, and how we do it is, this is shellac, which is normally solid, comes from trees, and here it's been dissolved in alcohol and it's fairly concentrated. So you're basically putting your parts on these brass plates, and you're trying to glue them down with a little bit of this liquefied shellac in an alcohol base. And then it gets put on a heater block. This is a block that you typically use for adjusting the jewels and pallet forks. And so Bergeon sells this heater in an escapement meter that you use in conjunction, but you use these plates for doing general heating and other things. And here Martin is baking off the alcohol in the solution and basically gluing things down. Part of the process, you have to keep everything held down while it's drying off. And here we are with the pieces glued down. Paul is showing here how you can set the height of these legs to a parallel level because we've got one extra part. And so you're using this tool to do that one extra part, and he's going through the process, showing the holder for that click. But these are the click springs. And so Steve is starting to do the polishing, flat polishing of these steel parts, or grinding, polishing. And then it's time for a break again. So you see it's got coffee. We got those, for both morning and afternoon. And here he's showing, he wanted to show us how the CAD system works. So he's showing how he would do the drawings in a CAD program and then transfer it to a machining program that generates the tool paths, and then you have a simulation engine that verifies that the machine's going to move the way that you want it before you actually put parts into the machine and start cutting. Here he's showing, the name engraving that will go onto the plate after the fact. And here he's, I think, showing the CAM program, doing the actual machining process. Here he's showing the CAM program machining our little nameplates. And these are the nameplates as they come off the brass stock. So to start off, they first drill the holes and countersink the holes, and then they engrave the names, and then they start doing this outer removal, milling of the outsides, and then a final pass cuts through the metal and does, a little part of it first, and then goes back and does another little part, and you end up with these pieces held on by just these little teeny sprues that you can then break away and polish off. So now we're done with our break, and we're done with our flat polishing, and Martin is going to show us how we get the parts off the plate. So it's basically alcohol put in a tin and then put back on the heater block. The alcohol is heated up, and the holders are put in the alcohol, and eventually the shellac dissolves, and you can carefully pull the pieces off, and you have to really handle them carefully, because even just picking these things up with tweezers, if you slip, you'll leave a visible scratch on it, and you get all the shellac off, and you're done. So here's my balance cock. It looks like this has been sandblasted already. So here you can, or bead blasted. We use glass beads to put a textured finish on the surface. So this has been done, and the main bridge plate hasn't been done. This is the inside of the bead blasting cabinet. So they're using fine glass beads to do this, and they're calling them pearls. The Swiss call it pearl blasting. I call it sand blasting or bead blasting. And you actually just hold the piece in there with your bare hand. So it's kind of a tabletop size machine. And you just kind of look through the window and decide when you've got enough done, and you pull your hand out and you got a bunch of these little glass bead dust on it, and your part. So here they are now finished, with kind of this smooth texture. So the next process that we're going to do is actually engrave Paul Gerber and Zurich on this. You can do the engraving beforehand, and what you see is it comes out looking like this, the plus and minus on the regulator part of the balance cock. The bottoms of the engraving get the textured look, and the edges of the engraving also gets the textured look. But they're back at the machining center, and the part gets clamped onto a fixture, and the machine goes through and does this engraving. So this is what you end up with. So you can see that you get a bright reflection off it, and the edges are sharp as compared to the rest of the surface. And so here I've got again this carbide burnisher. The bright edges of the plate have been textured, so we go back through and burnish those with the carbide polisher to make them bright. This is that toolkit for countersinking. There's the steel cutting bits, and then these are little ruby discs like jewels that are rounded on the edges, and those put a bright polish onto the holes that you're burnishing. So our work is getting inspected. Now it's time to plate. So we first would clean our parts in this ultrasonic cleaner in a solution, rinse them in the sink, blow them off the compressed air, and then they go into the plating tanks. And first thing we would do is plate them with gold. And so it's a real simple little setup that he's got using a power supply, and you hang your parts in there, and you go for a certain period of time and put the plating on it. Here we're looking at a watch cleaning machine. Everything has to go through the watch cleaning machine. Here I'm lacking in a lot of pictures. We started running out of time, and this is not unexpected when you haven't done this before. So we spent so much time talking and taking these morning and afternoon breaks, and now we're on the third day, and we got to get done. So Paul is working on or checking my movement. I think he's trying to figure out why I can't get my escape wheel chaton in, and figured out that there's a big chunk of sandpaper blocking the opening. This is my movement finished at this point, and then I'm all done with my watch and my little certificate saying I've gone through the school, and his wife Ruth is on the left, and she's again kind of his right-hand man. See, one thing I'd forgot to mention during the watch workshop is on the third day, Paul sits us all down. He says, okay, he takes my movement plates, and he says, we're going to, start assembling the watch. And so he assembles the motion works, and there's a little screw that holds the toggle lever that switches you between time setting and winding. And he tries to put the plate on, and the hole is in the wrong place. He had built plates for us for 6497s, not 6498s that we actually had. And that was the only time I've ever seen Paul curse. Mutters a bunch, and then goes to his CAD system and extracts the drilling process from the plate fabrication program. And we all had to take our main plates, or the plates that we had just finished, and put them back on the CNC machine and drill an additional hole there, and then chamfer the hole, and then clean and replate that plate so that we could go again. And so that added some extra delay on the last day, as you can imagine. And also all the jewels were set before we plated the bridges. So those jewels are all, exposed to these plating chemicals and such, but it's obviously not a problem. This is 2018, and Paul called me in the spring of 2018 and said, hey, two things. I've done a new balance cock with a fine regulator on it, and if you wanted to come for one day and do that, you can upgrade your school watch, which I was interested in. And then secondly, he was finishing up on that Piguet Muller Gerber ultra complication, and he was going to do a presentation on it. And he invited me to come see that presentation, and that it could come to his workshop and actually see the watch in person, which is pretty rare because insurance purposes limit, visibility of this watch. It's obviously, with 25 years of work into it, it has a lot of value. So here I'm back at Paul's workshop, and the gentleman in the blue on the left is Sebastian Chamonix. The person on the right is Magnus Bose. Sebastian is a lawyer by training, but was also a movement designer and a watch enthusiast. And when he was going through law school, he actually started his own watch company. But he became a practicing lawyer for a period of time, but hated it because a lot of times lawyers get called in at the last minute to deal with some things, on holiday or other times that are inconvenient. So he quit being a lawyer and became a full-time movement designer, and he also helped resurrect the brands Arnold & Son and Angelus. Arnold & Son has since been bought by the Japanese company Citizen, I believe. Magnus, people will know if you've been active in the community since the beginning, early 2000s, and the start of the internet. He was first on Time Zone and then Purist Pro. He's been a big supporter and fan of Paul Gerber, but he's also the operations guy behind the Ming Watch Company, which is based in Singapore. So this is a book that Sebastian co-authored, and this is, one of the kind of a Bible for chronograph collectors. And this is one of his watches that he designed that he was wearing that day. That's an Angelus Tourbillon, and he does this also in a dive watch version. And then this is the Ming watch that Magnus is collaborating on, designed by Ming Thiel, I think is the guy's name. And so this has actually got an interesting dial. It's a sapphire dial with a graduated fade on it. And this is superluminova printed on the inside of the crystal of this large high domed crystal. And this is a skeletonized movement in it, which is a standard Schwartz Entian twin barrel movement, but nicely finished. And I think this is about was about a $19,000 watch, possibly. Gentleman in the green is Alex Gottby, and he is a director at Phillips Auctions in Geneva. I think he handles primarily Europe and maybe the Near East, but again, he's another retired lawyer. It's something about the legal business drives people into watches. This is the box for the Muller complication. So Paul Gerber was asked to sort of create a whole package for it. So Magnus wrote this book on the history of this ultra complication, and the owner of the watch calls it Superbia Humanitas, which is sort of like the pride of humanity. Maybe that's a little bit of an overstatement, but it's still, a remarkable piece of work. So this is a pretty fancy box, and everybody's crowding around it, taking pictures, and and there's the watch. Everybody takes the pictures of it. So I'll get some pictures of the dial a little better. So this particular dial, we don't know who did the dial. That's an unknown, but Frank Muller contracted with Daniel Roth to create the platinum case. He contracted with somebody else to do the perpetual calendar movement. He didn't actually do the work himself. So it's a fairly complicated dial, all hand engine turned, a really nicely done job. Interesting problem with this watch is when you want to service it, the first thing you have to do is you have to pull the bezel off, remove all the hands, remove the dial, and then you have to take the perpetual calendar movement apart to be able to get the movement out of the watch. It takes Paul Gerber over a day just to get that done to the point where he can get the movement out of the watch case. You can see this up here. You've got this is actually equation of time, but it's also showing the months on it, and then days of the week, the calendar, seconds, and also minute accumulator. And then it's also a split second chronograph. And this is a thermometer down along the bottom with the gold hand. And this is the backside. So but you're looking at the split second complication on here, and that was added later. This is a power reserve indication coming off the twin barrels. That was the last thing to get added. And the first thing to get done was this flying tourbillon. And again, the specification by the owner of the watch, which I should say after Frank Muller finished the watch with the perpetual calendar. It had a standard, the original fixed escapement. He sold it at auction, and it was bought by noble, historic noble person in Switzerland. And he was the one that went hunting out a watchmaker that could turn the escapement into a tourbillon. And Paul Gerber was the only person that was willing to give it a try. And it had to use the original hairspring. And Paul had never done a tourbillon before, so it was a learning experience for Paul. And this is showing, again, just close-ups of the movement. It's just a mind-boggling amount of parts, and all these screws, Paul had to make himself. Close-up of the case with, some of the chime controls for silencing or allowing the Grand Sonnet to work. So the Grand Sonnet will strike the hours and quarter hours and half hour. It's enabled, so it takes a second barrel to do that, and then you can also chime out the hours on command by using the slide lever. So all of this had to also be added to the existing case. So I believe the back was raised up by this added lip, but all the original parts of the case had to be kept. So, these are some of the rapid sets for the perpetual calendar mechanism. And here we're, looking at the watch. This is the original watch that movement came out of, or the type of watch. I think that there's like some number known, and I don't remember, and I can't find my little book that I got from it, but that was the auction catalog. And this is what the movement looked like originally before all the modifications happened. And so here, so Sebastian is asking Paul about various things. He's asking about the power reserve indication. So here's a prototype bridge that Paul was showing. So in the early days, when he first did the tourbillon, he didn't have a CAD system. So how he made his small parts is he actually used an engraving pantograph. So he made these large models of the small pieces you wanted, and then he used this engraving pantograph to start cutting the steel out, and then you would finish it by hand with perhaps a jeweler saw, or maybe cut it all the way through. I don't know the process, but here, it's just kind of, doing all this by hand. This is definitely, pre-CAD days. And Alex is holding what was the tourbillon cage. Here Paul is describing how he used his jig boring machine to measure the watch. He basically had to create a drawing, CAD or pre-CAD drawings of the main plate of the watch movement and its bridges, and then he had to make his own bridge equivalent to try his cutting on, because he only could cut once on the antique plates, and he wanted to make sure he had it done right. So again, with these things, these are ultra precise readouts. And I actually got a tour of the Muller Machine Tool Museum by a guy that used to service Hauser jig bores for Bulova Watch Company in the United States. And he said that on these machines, there's a correction plate on these readout dials, and they have an ultra precise calibrated glass plate that they put on the base, and then they start moving the knob to each indicated position, and then they have a follower that follows a steel plate that moves this other readout piece on the top, and they file that plate for each position so that it's exact according to the glass calibration plate that they start with. So you're capable of reading down to micron kinds of resolution with these sorts of machines, even though they don't look like much. So there's one, tourbillon cage before it's all machined away. So obviously in this process, it's a very iterative process, and you make lots of trial parts that don't work. And, here he's showing examples of pieces that he's made and made again and made again and made again and made again until he finally got it working. So you can see why it took a long time. Now we're back to one day of doing the balance cock. So this is the new balance cock, and you can see the old balance cock doesn't have this fine regulator position for it. So I basically take my movements and take it all back apart, and then start going back through the same process with this balance cock. And I would say that I did a better job on my first balance cock than I did on the second balance cock. I think I was a little too cocky. I didn't get the angles done very well. This is a sandpaper stick that some people are familiar with. And I'm using these Zeiss dental type binocular eyepieces, and I've had really liked those. But I kind of struggled dealing with fine close-up work. And finally, on the last day I was there, Paul said, look, you got to give these things up. Learn to use a loop. And that was a really good piece of advice. I have since stopped using those binoculars viewers for the most part, and I had to make again another locating pins for the balance cock. And one of the problems I had was I'd always lose the pin when I was cutting it off. And so finally Paul's says, look, you got to grab the pin and do the sawing, and let the saw touch your fingertips, then you get the little part off which is sitting on there on the slide rest. And there I'm done with the bead blasting and polishing, and there's that ruby burnisher that used for putting the bright polish on all the screw holes. And there we've got the regulator back in. I forget this gentleman's name, but he had gone through the watch school program, and he was also part of this presentation, and then he also did this one-day class with me, or one-day session. And he wanted his regulator screw blued, and so they went through the bluing process. And so that's it.
Tim, what do you think that watch was worth that you showed us? Just curious.
The ultra complication, you mean, or
Yes.
the watch workshop?
No, the ultra complication watch.
I don't know.
Okay.
And I kind of wondered about that. The watch has changed ownership, and then it was the new owner that went through and had the split second complication added and the power reserve complication added. And then this most recent work was actually movement finishing. He wanted the watch more highly finished, and he wanted all the screw heads polished and finished, and so on and so forth. I mean, it's got to be worth several million. Just from the amount of time put into it. I was kind of wondering if he was getting ready to put it up for auction because he had this case made for it. He had this presentation, done that I'm assuming he paid for because Paul doesn't have the resources to host a bunch of people overnight at Prudential Castle, which is in Germany, and do a fancy meal. And part of the presentation, Paul talked at length about the watch and the process that he went through, but is all in German. And then there is a bit of a sort of panel discussion between Magnus Bose hosted the panel discussion, and Alex Gottby was there as part of an auction house representative. And I forget who else, but they never did say, what is this worth? I'm guessing the only way to know for sure is either it sells because two people agree on a price on any given day, or it goes up for auction and people then decide what the value really is. Other comments on watch workshop kind of things. There are other companies that are offering these kinds of watch workshops. Longue and Son, they will offer that, but you have to be, a customer of theirs of the right size to get much in the way of attention from them. There are some guys in Geneva that are offering several different levels of build your own watch programs, and there I think it's more you take a movement and put it in a case and add a dial, kind of a one-day thing along with fancy meal and in between and some other things like that. The AWI, American Watch Institute, they have some programs for their members on build a watch. And then finally, the Horological Society of New York, they have a 4-hour 101 program that both Rex Pogenpol and I have done in Denver back in, was that 2019 or 2020? I don't remember anymore when we did it, but there you take the same ETA movement and take it apart and put it back together. And then you also get a bunch of watch theory in between. Any other questions or comments? Anything else we want to talk about?
Well, thanks for your presentation on Gerber. I know his synchrons are running at 50,000 or over. What would the market have for his lowest price watch?
Okay,
20 grand or something?
they're not that high. The watch that would be that expensive is caliber 33, which is that kind of rectangular shaped watch, which I didn't show any pictures of.
I remember it. Yeah.
And then the synchrons, those are based on the 28 24 movements, and those are actually for the time only versions, those are just a smidgen over 5,000. And then the ones with the 24-hour second time zone, those are another 1,000. And Keith Hurdle has both the synchron and just kind of more the Flieger, the pilot style watch in both the single time and dual time zone versions, in his store now. I forgot to show watches in my collection.
Yeah.
So I'll do that. Just these are all watches that are either Paul Gerber or Paul Gerber themed. And this first one is his caliber 41. And so that's what he makes in-house, and that's the movement side of it. And you can see the button there for toggling between start and stop. This is the first watch that I had bought off Time Zone, and this is a sterling silver cased retrograde seconds watch. So basically, there's a sub-second, small second movement in here with a cam on it, and then this thing, the second hand, has a little follower and a hairspring that forces it against the follower against that snail-shaped cam. And so as it rides up the cam, it goes over to 60, and then it hits the cliff and falls off and snaps back to 0. It's a fairly, really simple concept. But it's surprising how many crazy different retrograde designs that there are out there. And that's the case back. And then this is a retro twin. These are smaller watches, about 33 millimeters, flat silver dial that is machined on that his first machining center. And that's the movement on the backside. So it's based on I'm going to pronounce it wrong, a Paceau 7000 series movement. It's a small movement. It would almost be considered a women's size movement today. So another retro twin. This one has a power reserve indicator on it, and it's a little crazy because this hand is just hard tied to the movement, and then the disc behind it also moves, and that's tied to the winding part of it. So as you wind it up, the disc moves till the hand, hits 36, and then the hand rotates down as the watch winds down to 0. And again, the backside. And then this is my school watch. Paul machined a metal dial for me and hands and sent them to me. So this says watch school in text in the background. And then this is a most recent thing. It's a little quartz-based moon phase module that fits on a strap, and you can either add it to your own strap or buy it on a strap. And then this is the MIH watch, which again, as I said, is based on a 7751. So they actually have the minute accumulator on the back side of the watch visible through the back. And then this is the Fortis alarm watch that Paul Gerber did the movement on. So this button on the lower left at 8 o'clock toggles this flag between orange and black, and indicating whether or not the alarm is enabled. This hand here is the alarm indicator. So when you pull the crown out to the setting position, if you rotate down, you move the alarm hand, and if you rotate up, you change the date. And then backside here, the winding rotor for the 7750, which this is based on, is deeply extended, and so it's really tall and it creates space. This is an extra bridge for a little like a women's size mainspring barrel. And this is part of the alarm function. There's basically a pin that goes through the movement to the backside that releases the hammer and allows the hammer to strike. So this is a Marine Master version of that same watch. And so this is showing the tines that the hammer strikes, and you can sort of hear it. And then these are really thick watches. These are like 3/4 of an inch thick. So they're not exactly fit under your shirt sleeve kind of watch. Okay. All right. Well, I will go ahead and pull the plug on this then. Thank you all for attending.